Today we're going to be talking about different types of Z transforms. So I'm studying for the breadth exam at UNCC and came across a question that asked if a filter has Z transform H of Z, which is equal to Z cubed plus 2Z plus 2 divided by 5Z cubed with a regions of convergence greater than 0, then the filter is A, unstable, B, left-sided, C, two-sided, or D, causal, or none of the above. So if we look at this problem, when we are given a regions of convergence, one of the things that we can automatically remove from this selection is unstable, because the regions of convergence implies that we are bounded. So when x of z is outside of the region of convergence, then our system becomes unstable. But since all Z transform must give an ROC, we are stable. Now, the question becomes, is it left-sided? In order to understand if it is left-sided, we can address if it is a right-sided causal system. So how do we determine if it is right-sided and causal? We would know that by first looking at if the system has a regions of convergence outside its outermost pole. So what are the poles? The poles are when the denominator equals 0. So when we set 5z cubed equal to 0, we get z equal to 0 would make 5z cubed equal 0. When we look at the zeros, we equate the numerator to 0. So in order for the numerator to be 0, we set z cubed plus 2z plus 2 equal to 0. Since we know that the regions of convergence is when z is greater than 0, then we can easily draw the unit circle graph and portray that. In order for it to be a causal system, the regions of convergence must be outside our outermost pole. And if our pole, which we've defined to be z equals 0, is in the center and our regions of convergence is outside of it, then we have a causal system. Now, by that definition, it cannot be left-sided, because any right-sided causal system cannot be left-sided. Now, just for definition's sake, what would a left-sided system look like is a good question. So when you look up what a left-sided solution would look like, you would see that your region of convergence must be inside your innermost pole. So let's say the region of convergence was z greater than 0.5. Sorry, was z less than 0.5, or the magnitude of z less than 0.5. At that point, we would say that we would have a left-sided, given the same problem where we have 5z cubed plus some c in order to get 0.5 as our pole. For the two-sided, we would need a region of convergence that is bounded by an upper and lower limit. Since we do not see that, we can rule that answer out as well. Having thought about all the possible answers, D is the right answer.